Hola, my name is Pamela. Welcome to my channel. Today I'm gonna talk about the radiometric measurement system consists of a gamma ray emitter mounted vertically on one side of the tank and a Geiger counter that transforms the received gamma radiation into a direct current electrical signal. Another type of detector consists of a bundle of optical fibers that transmit the luminous photons created in the crystalline structure, equipped with doping materials, when they receive gamma radiation to a photomultiplier tube. As the transmission of the rays is inversely proportional to the mass of the liquid in the tank, the radiation captured by the receiver is inversely proportional to the level of the liquid, since the material absorbs part of the energy emitted. The rays emitted by the source are like X-rays, but with a shorter wavelength. The radioactive source also loses its radioactivity as an exponential function of time. The time necessary for the emitter to lose half of its activity varies according to the source used. In cobalt-60, it is 5.3 years. In cesium-137, it is 33. In americium, 2041, it is 4,058 years. Continuous measurement requires that the electronics have automatic compensation for drift due to the radioactive decay of the source. Its precision is plus minus 0.5 to plus minus 2% of the measurement field. The tank walls absorb part of the radiation and only a small percentage reaches the detector. The detectors are generally Geiger tubes or ion chamber and use either DC or AC amplifiers. As advantages, the instrument has temperature compensation, linearization of the output signal, and readjustment of the loss of activity of the radiation source, which is very important to preserve the precision of the startup. It can be used to measure any type of liquid because it is not in contact with the process. It is used in tanks that are difficult or dangerous to access, or when there are high pressures inside the tank that prevent the use of other measurement systems. As disadvantages, we have the shielding of the source. It is expensive. Its installation should not offer danger of radioactive contamination. It is necessary to indicate the areas where these instruments are installed. Periodic safety inspections must be made, and compliance must be guaranteed of radiation protection laws, which in Spain are regulated by the Nuclear Safety Council. The design, installation, and maintenance of these methods must comply with the regulations and on what we can see in the screen. In addition, before its installation, the appropriate documentation must be processed for the Nuclear Safety Council to authorize it. The personnel working with these methods must have adequate training and follow the special safety regulations given by the manufacturer, with the guarantee of the nuclear authorities. And we have license as a supervisor or operator of radioactive facilities, obtained by the Nuclear Safety Council. The intensity of the radiation received by the detector depends on the isotope of the emitter, the density and other characteristics of the liquid, the thickness of the insulation, and the distance emitter-receiver, preferring the method in which the radiation source is of lower activity. Microprocessors have provided greater sensitivity to this type of level measurement, allowing a longer duration of use of the source and greater safety for personnel, since the source can be used with lower levels of radiation. And well, this will be all for today's video. Don't forget to give me a like, subscribe, and share. I upload videos every Wednesday in Spanish and every Friday in English. Adios! But with a shorter wave, varies accordingly. The time necessary for emitter to lose half of its precision is 5, allowing a longer